All right, bell work. And I know you were gone for the week, or that we had a long weekend, kind of. Well, it seems long since it's Tuesday. I always think of that as a long weekend because it's been since Friday since you've been here. All right, so we have that formula, and it says write a rule that gives y as a function p of p, x, and w. And that means we have to have y solved by itself because that means it's a function of those other variables. Okay? So it's basically telling us to solve for y. Okay, so if I start with my original equation and I want to get y by itself, how do I start? Megan?
To get y by itself, you get times w.
Multiply by w on both sides. Whatever I do to one side, I must do the other. So my w's cancel out. So now I have w times p equals x times y. So now what? Somebody else. Yes, Harley. By x. And so we end up having w times p over x equals y. This is, or this will be, a test type question. I'm dead serious. Okay? Now, one that gives w as a function of px and y. So start out with my original. Again, it's just a fancy way of saying solve for w. Somebody, help me out. Multiply by w, okay. And please rewrite your equation and don't try and do it all at once. I can because I've taken a tremendous amount of math, but I still write everything out. I'm still in that habit because showing your work in math is about communication. If you can communicate your logical thinking with others, so showing your work is basically like explaining clearly. Okay, now what? Divide by p. And I end up having w equals x, y over p. Very good. All right, now, how will p change as w increases? So I'm going to... How will p change as w increases? So if w increases, what happens to p?
Decrease.
Why?
It's getting into smaller pieces.
It's getting cut into smaller pieces?
No, it's getting cut into more.
Into more pieces, into smaller pieces. Same thing. Because if it's into smaller pieces, it's smaller numbers. But yes, it's getting cut into more pieces. That is division. Because this is a direct or inverse relation. Inverse. P and W are related in an inverse fashion. All right, now how will P change as Y increases? Somebody else. Alexis?
It'll increase.
Okay, P will increase. Why?
Because there's more pieces. Like the number on the top will be bigger, and you'll still be dividing it by the same amount.
There we go. There we go. The number on the top is bigger, and you're cutting that into the same amount. So if you're dividing a larger number by the same amount, it's a larger number in result. Yes. Because it's a direct relation. But yes, you are absolutely correct. The short answer is that they're related directly, but that's the deeper answer for sure. All right, now I will have one thing here, and it's basically just one more of these. And I want your table. You're just going to be telling your shoulder partner your tables. Is that okay? That makes sense? And I'm just going to be randomly calling. So if I see you not participating, I'm going to assume that you know this so well that you can ignore what I'm telling you to do. So this is basically just like the bell work. Let's say I have z equals k times x, y, x times y. And all the numbers are positive. Z, x, k, and y are positive. So a way of representing that is saying that they're greater than 0. That's what they're all positive is a way of showing that. All right, so now let's see. If x is held constant and y increases, what happens to z? Tell your shoulder partner. Tell your tables. All right, who believes they can give me a very clear and concise answer? I want to hear from someone I haven't heard from. Kaylee Yackel.
If x is constant and y increases, then that means that z will increase because we're still multiplying them together.
Z will increase because we're still multiplying them together. Excellent answer. And it is a direct relation because z and y are related directly. We have multiplication. And very good. All right, now let's say x is held constant and y decreases. Tell your table mates. Go. All right, can I hear from Tyra's table? So then, y will decrease also. Okay, why is that? Because they're directly proportional, and we are multiplying by a smaller number all of a sudden. So if we're multiplying by a smaller number than the original, it would have decreased. All right, so now, let's say we have this inverse relation or partially inverse relation. And these were, once again, they're all positive, just so we simplify that thinking a little bit. All right, so x is held constant and y increases. What happens to z? Go. Okay, I haven't heard much from my table right in front of me, so Jesse's table. What do you guys think? Z will decrease? Okay, why will z decrease?
Because you're
Dividing by a bigger number, and we have what type of proportion? Direct, inverse, neither? Inverse? Inverse it is. All right, so we have this same equation right here. And let's say x is held constant and y decreases. Go. What happens to z? All right, Porter, your table. Z will increase because it's an inverse relationship. Very good. We're cutting them into smaller pieces. All right, now, one last thing. here is these prompts. You're going to tell your shoulder partners, just the person next to you. Z is blank proportional with X, and Z is blank proportional with Y. Go. Talk. All right, just answer as a class. Z is what type of proportion with X? What do we think? Direct, inverse? Raise your hand if you believe direct. Raise your hand if you believe inverse. Okay. With direct relation, right here. If X would increase and I'm dividing by the same amount, Z would increase. So this is directly proportional. All right, so Z is what proportional with Y? Answer as class. Inverse. Wonderful. It is inversely proportional.